Hello viewers! Welcome to our very first video tutorial. We will present to you a brief discussion about the OSI reference model. To start with, let's find out what does OSI model mean. OSI stands for Open Systems Interconnection. It is a networking reference model defined by the International Organization for Standardization or ISO to organize networking of devices from different vendors. The OSI reference model is mostly an architecture blueprint that networking and computer device manufacturers implement. The OSI reference model is designed in 7 functional layers. In layer 7, we have the application. Layer 6, presentation. Layer 5, session. Layer 4, transport. Layer 3, network. Layer 2, data link. And in layer 1, physical. The layers application, presentation, and sessions are what we call the upper layers, while the transport, network, data link, and physical are the lower layers. The application layer is responsible for application-specific end-user processes and is the closest layer to the actual end user. Typical functions of the application layer include communication synchronization, resource availability determination, and identification of partners for communication. Some examples of application layer protocols include Hypertext Transfer Protocol or HTTP, File Transfer Protocol or FTP, Simple Mail Transfer Protocol. The presentation layer, also referred to as the syntax layer, formats and encrypts data over the network. It also provides data to the application layer in a format it can understand. Translation is performed between application and network formats, ensuring that no compatibility issues exist. The session layer is responsible for controlling computer connections between local and remote applications. It initiates, controls, and terminates sessions using full duplex, half duplex, or simplex operations. The fourth layer, which is the transport layer, provides seamless data transfer between computer systems using flow control and end-to-end error recovery, keeping track of datagram delivery and retransmitting lost packets. TCP and the connectionless UDP operate at this level. The network layer at layer 3 is responsible for transporting data between networks and is also called the routing layer. All routed networks connected to the Internet function at this level using the Internet protocol, and data is transferred in a series of hops. Internetworking, switching, routing, addressing, error handling, congestion control, and packet sequencing are handled here. Layer 2, or the data link layer, resides above and manages errors from the physical layer and is divided into 2 sublayers, namely Media Access Control Layer and the Logical Link Control Layer. The MAC layer is useful for controlling network access, while the LLC layer is responsible for frame synchronization, flow control, and error checking. The data link layer also encodes and decodes data packets into bits and manages errors from the physical layer, promoting reliable delivery in the physical medium. The bottom layer of the OSI, which is the physical layer, defines the physical hardware used on the network, such as the network interface cards, host, bus adapters, repeaters, hubs, and cabling. Protocol data units, or PDUs, are the basic data container used by each protocol to exchange data between hosts in a network. Each PDU contains a data payload and control information that helps the protocol to figure out what to do with the data payload. The control information is usually stored in the header of the protocol data unit and sometimes in the trailer as well. The protocol data unit at the application layer is the data itself, such as the text of an email message. This data is then converted, encrypted, and translated at the presentation layer and encapsulated in control information headers to allow the receiving host to reconvert and unencrypt the data to its original format. The data is then further augmented with the session layer control information when an authenticated session is opened between the communicating hosts at the session layer. The data at the session layer is then handed down to the layer 4, which is the transport layer. The transport layer first divides the session layer protocol data unit into several small data chunks called segments. Each segment is numbered so that the receiving host can reassemble the application data. These segments are then forwarded down to the network layer, which tags each segment with the logical source and destination addresses and some routing information, and hands over the resulting shippable data packet to the lower data link layer. The data link layer builds a data link frame by adding the physical source addresses of the sender and the physical destination address of the receiver, if the receiver is located in the same local network as the sender. If the receiver is not located in the same local network as the sender, the data link layer adds the physical destination address of the gateway in the local network to the data link frame. The gateway of a local network is usually a router that connects the local network to other networks. The data link protocol data unit is handed down to the physical layer. The physical layer will then convert each data link frame into a series of binary signals. The binary signals are then transmitted over a wired or wireless connection to the next physical hop. So this is how the data is being encapsulated as it passes through the different layers of the OSI model. The data unit at the application layer, presentation layer, and the session layer is called user data. When it reaches the layer 4, the data is called segment. When it reaches the network layer, it is called packets. And when the data reaches the data link layer, it is called frames. And then these frames will then be converted into a series of binary signals at the physical layer. From the sending host, the data flows from the application layer down to the physical layer. The physical layer of the sending host will then transmit signals to the physical layer of the receiving host. Thus, the receiving host receives the data and how it is originally formatted by the sending host.
This is the end of our presentation. Hope you learned about the OSI layer. Thank you for watching.
Tara na't mag-selfie, selfie, selfie, selfie tayo pang may time. Ipakita sa mundo ang maganda mong smile. Selfie, 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 selfie tayo pang may time. Ang pagiging maganda at pogi rin a crime. Selfie, selfie din pag may time. Selfing malungkot, meron din yung masaya. Meron din yung nakanguso, tila pato ang ginagaya. Selfie ng bagong damit, o kaya bagong gupit. Meron yung waki at pa-cute, at yung kunwari ay galit. Oh